Hello and welcome to building a Stella 1.2, the newer version. Here are the Stella 1.2 tools you'll need. You'll need a solder iron, breadboard, snips, wire stripper, multimeter, hobby knife, tape, pliers, marker, and safety glasses. It is also recommended to use a solder fume extractor if you have access to one. Stella 1.2 parts. These are the parts you will need to assemble your Stella. You will need a proto board, an ESP32S microcontroller, 3-pin and 4-pin magnetic connectors, an I-SPI breakout, an RTC clock breakout, GPS breakout, Rotary encoder, 2.8-inch screen, 3 times 10K ohm resistors, and one 0.1 microfarad capacitor. You will also need a quick buzzer, a 5-volt boost breakout, power push button, an SD card breakout, an I-SPI cable, a CR1220 battery, and a 6600 milliamp hour battery. Three parts that you'll need to print out or have printed out. You'll need the assembly base, you'll need the attachments for the assembly base, the micro SD attachment, the 3 and 4 pin alignment, and the RTC spacer, the upper housing and lower housing, buzzer retainer, GPS window, record window, tail window, and swing door. Many of those require the housings and will be attached to the housings. The ones on the assembly, they're there for support for some of your breakouts. Now to start building, we use the assembly base and we put our proto board on top of it and we cut our traces. Okay, so there's our assembly board. And we put the proto board on our assembly board, on our assembly stand. And then I like to get the marker out and mark the corner of A1 on the rear so that I can make sure that I have it, I'm cutting the right traces and wiring the right areas, especially if I'm flipping over to the back. Okay, so I made that mark there. All right, now, and making sure to double check. Okay, always good to double check. And eventually I'll get my utility knife there and I will start looking at the traces and make sure that I'm cutting the traces. And remember, you're cutting just 2 traces from AB to BC to CD, so basically just 2 back in those rows. Okay, and it takes a little bit of doing, so I like to cut a few times and then see if I can dig out, the little pieces of the trace as I go along. All right. And we'll move to the upper areas where we do the I and the J, between the I and the H. Okay, so just 2 up the top and 3 at the bottom near the A, and then we test for bridging with our multimeter. Okay, so I turn it to the beep function, test the beep function, make sure that's beeping. Okay, and we're testing for any kind of bridging or any kind of unwanted bridging. And I also check some of the traces, especially the longer traces down at the bottom, just because I've ran into the incident where it was cut down at the bottom, and it took me a while to find. So now we're going to install the couplers. Okay, and this is where you need the coupler alignment. And for this one, for the base module, you're going to need the flat couplers, coupler alignment. Okay, so the one that says pins on it, you do not need. Once we have our alignment and our pins on there, we're going to go ahead and tape the alignment print down, and of course keep it some room so that you're not taping over the solder points. Okay, and you can see those pins coming through there in the holes on the proto board. All right, always double check, make sure that it's all staying straight. Now I'm going to put a little bit of solder on there, or a little bit of flux on there with the flux pen, and I'm going to solder these couplers. Make sure you clean off the solder iron. Okay, and now we're good to go. We're going to go ahead and make sure you touch the metal on both the pin and the rim. Okay, while you're putting the solder in here, heating them up. And you don't need a ton of solder for this. So I pretty much just fill in the areas and release. Okay, and then we're going to peel the tape off, pull that out, make sure it looks good, and then test for in case there might be any bridging. Okay, this is definitely a point, an area where that would be unwanted bridging if there's going to be some. Okay. We're checking. Okay, now we're on to the next portion. This next area, we will be testing the microcontroller. So we test it before we solder it into our proto board. Okay, so you're going to need a USB-C cable, and you hook it into the port there on the board. Okay, and you might have to do reset boot, and that should take you to the feather boot. There's the reset and with the little arrow, and boot is the other button. Okay, and you connect it in there, you hook up your Mu editor. Now you drag and drop your UF2 file into the feather boot area. It's going to take a second, and when it does, it's going to eventually pop up back up as circuit play. Okay, and then you drag and drop your code.py and your libraries all in there, and make sure it works. Okay, and now we install the microcontroller once it's up and working. All right, now you want to use the headers, and you want to make sure that the longer pins are going through the microprocessor board, and that's because there might be an attachment later on that you can put on top of it. So when you're soldering this in, and I'm just using the proto board here as a stand to solder these in, so I'm not soldering it to the proto board quite yet on this. I'm soldering the headers in. Make sure you just put a little bit of solder at the base of the headers. Okay, you want to make sure that the top of the header pins there are clean in case we do put attachments on that later on. Okay, and we're going to go ahead and again just using this as a stand at the moment to solder these in. Okay, because this will actually be soldered into the proto board on the rear of the proto board. And the solder's kind of tiny. Go ahead and retin the solder iron, and again make sure that you're cleaning off your solder iron very well. So don't do too many of these pins all together in the combination before cleaning it off. Keeping your solder iron tip nice and clean is good. Okay, make sure that those headers are nice and flush, and then we put it on the back. Okay, from C44 to C59, I44 to I55. Make sure you double check that, and I'll use a little bit of tape to hold that in there. Okay, and what I like to do is put a little solder, usually at some of the ends of the header pins. Okay, and then make sure that those headers are sitting flush. If they're not, I can adjust them. So I did it on 2 areas there. So now I'm pushing down on the board and making sure that those headers are sitting flush, making sure there's no gaps. Once I do that, then I continue soldering the rest of the header pins in. And again, you want to make sort of tiny little volcanoes. You don't need big globules of solder on there. making sure to use the solder tip between touching both the pin and the rim. I gotta say, I find it very relaxing to do these. So this is a very fun build, and you can thank Paul Morell for that. He made a really fun device to put together. Okay, and now we're going to start wiring this microprocessor on in. And I'm starting with the ground, and I'm measuring the distance here, and then we're going to put our ground wire from A56 to the ground below A, our power wire from A57 to the positive below A, and then our green wire from J45 to the negative above J, and our white wire from J44 to the positive above J. Like to measure, make sure they fit, put them all in there. So, okay. Bend the wires back a little bit so they stay, and add a few more. I don't think I do more than 4 or 5 wires at a time, just to make sure. And even then, sometimes it can be a little confusing. So put a little flux on there, and solder these on in. And clean our board up. Use the snips, take some of that excess wire off of there. Okay. Alright, so now we're going to get ready to wire our couplers. Okay, and this is going to be a change from the older version. This is one of the first changes. Okay, so we're going to put our ground wire from B2 to B1 to ground below 2A. We're going to use our red or power wire from A2 to A1 to the positive below 2A. And then we're going to use our white SDA, and we're going to put it from A, or E1 to above 2J. And then we're going to use our green or SCL wire from C2 to C1 and then above 2J on the negative bus. Okay. And one of the reasons that we changed it up this way is you can we're trying to make it a little easier to use a 4-pin coupler with a quick connect and test out different sensors. And it should make it a little bit easier to do so without having to do a whole bunch of excess wiring. Now, so I make a little extra length when it's going to the couplers. That way I can lay them across the front there, because you are going to bridge those areas, and you'll see what I mean. So you see how those wires are going right across the front there? So I'm going to bridge those areas. So we don't want them bridging down, we want them bridging across, combining those rows. And after I finish soldering and cleaning up, I'm going to use my multimeter to check to make sure there is no bridging, unwanted bridging. Because this is, again, one of the main areas where unwanted bridging would happen, if it were to happen. There we go, grabbing the multimeter, turning it to the beep test, testing for unwanted bridging. Alright, now we are going to test and set the time clock. Okay, so we are going to use a quick connect cable, and we are going to hook the time clock breakout. Make sure you have the battery in there first. and we are going to set that time clock. And Paul Morrell has made a simplified version of being able to do this using the Mu editor. Next, we're going to make sure that the USB-C is connected to our chip and our computer. We're going to go to our test codes, go to clock set, drag and drop into the circuit Pi, let it load up, check out our serial on our Mu editor. We can check with time.is/UTC, okay, and make sure that we have the correct date and time, and we enter all of those fields in, and then our clock is set. Once you get through all of this, make sure you hit enter, and we're sound as a pound. So we put our time into our RTC module, and now we need to pull it out. We're going to pull out the quick connect and this module as well, and we're going to go start building on our proto board again with the Rotary encoder. We'll get back to the clock module later. Okay, so for the Rotary encoder, you trim off the 2 fat pins on there. Okay, I like to make sure they're nice and flush. There you go, with the sides. So go ahead and clip those off. Boom. It takes a little doing with your snips. Okay. And then we're going to line those up with the holes there and push them on in. There we go. So H37 and H39, D37, D38, and D39. So it's always good to check a few times and make sure that that's where the pins are going through. And then flux, a little solder. I only soldered one in to start because I want to make sure it's flush. Okay, and I push down on the thing. While I soldered in. Okay, to make sure that it's sitting flush with the board. Okay, and then once I make sure it's all there, I go ahead and finish soldering in the rest of the pins. Okay, and that might be an advanced technique. Be careful, don't burn yourself. Alright, now I'm just putting a little bit of the hardware on the top. I'm not putting the actual cap on quite yet. Now we get to wire it in. 38 to the ground, the negative below A, F35 to the negative below A, I35 to I37. Okay. And you can test it out with the multimeter to make sure that it's all functioning correctly, that it's all bridged well. Once you have the ground wires soldered in, then we move on to the rest of the wires for the encoder, and that would be the purple wire from B39 to B51, white wire from B37 to B52, and the blue wire from I39 to B53. Make sure the wire is all nice and steady there. Okay, and once that's all soldered in there, make sure you clean it up. Again, if you feel like there might be a bridging problem, there's always good to check. these up here. Make sure this got enough solder. There we go. All right. Now you plug into the USB-C back into the microcontroller and bring up the screen, and you go to the Rotary encoder under the test codes, and you drag and drop the code.py into the CircuitPy folder. Okay, drive. And then you twist and push the Rotary encoder while you're looking at the serial, and you should hopefully see, as you're twisting and prodding it and pushing it, numbers come up and that it's been pushed. Now we're going to go into the display breakout. Okay, so you're going to need your iSpy display breakout, your iSpy cable, and all that. Okay, so we're going to check the board here. Just get to clean ourselves up a little bit. It does get messy. All right, so we got our iSpy breakout. It's in the lower portion of the screen. Now we are going to solder it on the front with the black latch bar towards J. Okay, and it goes into slots D24 to 32 and G24 to 32. So make sure those are correct. Okay, and you can see that the black latch bar is pointed towards the J. All right, and then as before, like with the microcontroller, I like to make a nice stable platform. So I'm just doing the four corners first. All right, there we go. Nice little touch up. Then I'm going to tape it down. Okay, I'm going to do a little flux there, and we'll solder maybe a pin or two on the headers. Okay, and I'm going to take that off, and I want to make sure that those headers and the board are all flush. Okay, and now I'll go ahead and continue soldering the rest of the header and the headers in. And then after I finish soldering these headers in, I'll take it over to the trash can, and I will snip them off and clean up those pins if they're sticking out very far. Okay. Okay, so having freshly cleaned the board, we're going to go ahead and pop some wires in here. So we're going to put our red power wire from A24 to positive below A, our ground wire from A26 to the ground below A, and then the green SCL negative to above J from J27. Okay, and then white J28 to the SDA positive above J. And sometimes you might make a mistake. I've definitely made one or two before where I've put a nice SDL into the or SCL to the SDA line and so on and so forth. So it's always worth checking to make sure that you got green with green, white with white, black with black, red with red. Alright, and then we're going to solder some more breakout wires. In this case, we're going to do white from A32 to J51, gray from B30 to J50, blue from A29 to A47, green from A28 to A48, yellow from A27 to A49. Again, this is also a bit of a difference from the old version. I will put up a video about how you can convert your older 1.2 build to the newer one. and it's actually only just a few wires that you have to trim and put into some slightly different positions. Alright, let's finish up soldering here. Make sure the board is clean. Finish doing some clipping. Alright, now we're going to get our display. And our display has 3 jumpers on there. And the 3 jumpers we need to close. We need to make sure and solder those shut. And that would be IM1, IM2, and IM3. Do not do IM0. Okay, make sure that those are completely soldered and bridged. And then we're going to get our iSpy cable and hook up our microprocessor to the USB and connect our display. Okay, and now when you put your iSpy cable in there, make sure that fit it nice and snug. Okay, it does go in just a bit. Alright, and now my screen is on, which is a good sign, but then we're going to actually test it. And to do so, you go to the display under your test codes, drag it into the Circuit Pi, okay, let it boot up, and when it comes up, you should see on your screen basically a nice, red border with blue. It should say Stella, and then might say, go counting down 1 to 2, 3. Once you have that, then you pop in your Circuit Pi for your touch screen, okay, and with your touch screen, all right, your screen should be lit up, but you open up your MU editor, okay, and open up down to serial, and when you touch the screen, it should show that you're pushing it, sort of coordinates where your fingers are. So now we're going to install our 5-volt boost. Alright, this is a smaller module, very important. Okay, so we're going to solder header pins from G17 to G20. Again, I like to maybe solder just one point on there to start once I have it in there, and I want to then make sure that, in this case I'm taping it up, but I want to make sure it's flush and straight. Okay, there we go. Taking a quick look at it, looks pretty darn good. Okay, we'll finish soldering the rest of it in there. And again, you don't need much solder, you just want to sort of coat the base a little bit. Okay. Now we're going to solder in the resistors there in the front. You're going to need 3 10K ohm resistors from H20 to H23, one from H16 to H19, and one from G13 to G16. And I wanted to try to get these as close to the board as possible when I am soldering them down, so I make sure that they're pretty darn flush when I get in there. And you'll see that in just a second. And the reason is that the 5-volt boost breakout board is actually going to go over top. Okay, so I'm going to make sure that these are all spread out. So I get out my pliers and I make sure and pull it down pretty hard. Okay, I don't want to pull them out, but I want to pull it down pretty hard so that it's as close to the base of the proto board as possible. So I'll take my time doing a little bit of that. All right, there we go. And not much solder. Make sure you make contact with the wire and with the ring. Clean the board up. Okay, now we're going to some solder, some more wires here for the, and those wires will be ground wire from F13 to the ground below A, so black wire there. Black wire from J13 to J18. Black wire from I18 to I23. And a white wire from J20 to J49. And remember, if you're going near the header, especially towards the J area, that you want to try and lay it pretty flat, those wires, because you will have a module going over top. And you'll notice I left just a little bit of slack in the F13 area. And the reason for that slack is you'll find out a little bit later, or pretty much in the next portion of this after you test the boost module. It's going to be for the time clock module, which is a very fun one. But you need a 3D spacer to put there, so you need to leave a little slack in the F13. So we have a few more wires to pop in here from I16 to B54. Okay, that'll be yellow, brown from J12 to J55. Okay, brown from I12 to J17, and an orange, and this one is going to be part of the coupler, is going to be from J2 to J1, okay, and then J19. So the orange is going to go from basically J2 to J19, but you need to leave a little excess underneath there so that it can hit that J1 coupler area. And again, I like to try and keep things flat and try and find a little space for the wires to go into so that they don't bunch up, okay, because that boost module will be coming in here at the end. And you can see the top of my hair there. Alright, once we have that board cleaned up and ready to go, now we start soldering in our 5-volt boost component towards the J, from G17 to G20 on those headers, on those header pins. Okay, and this is where you'll see that it's very useful to have basically made those wires under that area pretty flat, as well as the resistors. Okay, and just solder in those 4 pins. Okay, little volcanoes if you can. And now we hook up our computer into our microprocessor and test out the 5-volt boost. So we're going to drag and drop our test code 5-volt boost in there, and if you take a look at the serial on your Mu editor, you will see a little readout. Okay, and if it's all working well, it's good to go. Next, we're going to build the time clock. We're going to put the time clock onto our board here. Okay, and first you get to cut the LED jumper on the time clock. Okay, so there's a little jumper on the front there, and you just take your knife and score it, and you can even use your multimeter to see if there's any bridging to make sure that it's actually scored correctly. Make sure your battery is in your time clock, of course, and the good thing is you've already set it. Now, when you put in your header in here in the 3D print and all that, you want to make sure it fits into the 3D print. So I'm cleaning it up a little bit off camera there, making sure it fits into that 3D printer mold. Okay, and once I do that, I will pop it onto the proto board with the time clock in there, and you'll see I'll move the wire out of the way a little bit. Okay, make sure it's flush, make sure it's in the right pins, right holes that is, and go ahead and do a little soldering on top here to make sure that the header is all flushed in there. Okay, and go on the back and do the same. Okay, and right now I'm just basically tightening it up and do a little bit more soldering. Alright, let's get back on that board there. Okay, so finish soldering up here. Okay, and this is actually probably my favorite piece to go through now, and that reason will become very apparent. So the black wire from A19 to the ground below A, the red wire from A20 to the positive below A. The fun stuff is where you get to put the green wire, the SCL wire, from A18, and then you put it underneath the spacer, okay, to the right, and then you bring it to the minus above, okay, and you can tighten that up. Then you do the same with the white one from A17 to the ASDA, positive above J, okay. I thought that was a lot of fun. There we go. So we're putting it underneath and we're pulling it through, okay, and we're closing that loop there. And now we have that wire nice and, I don't know, there's just something satisfying about it, in my opinion. And quite brilliant. Tuck that in. Okay, strip the wire a bit. Alright, there we go. I'm going to solder all of that. Let's clean up our board. There we go. Looking pretty good here. Okay, now we're going to test our time clock. And you know how to do that. That's pretty simple. So you go to the time clock, test and drop, boom, and it should appear with the time and date that you set previously. and that'll show up in the serial portion of the Mu editor. Okay, and once we have that established and it's all good, all right, then we will move on to the next portion, which would be the analog input. And this is a relatively simple one. This is just a wire here going to your coupler. Okay, so it's going to be a blue wire from I2 to I1 to B55. So basically it's going to go from B55 to your I2, leave a little extra wire there, and it will run to your I1. And then you'll bridge that all up, okay? So it's a relatively long wire. Okay, we're going to flux that on up and we're going to solder that on in. Okay, and that's going to be your analog input. And you see that goes along with your 5-volt coupler up there. And we use that for a few different devices, a few different sensors. Okay, we're going to install the SD and GPS. So we're going to install headers from B3 to B11, from H3 to H11. Okay, so I'm just seeing the space here, boom, breaking it off. Okay, and we'll get 2 of them, same size, and we'll take a look, and we install it on the rear of our proto board here. Okay, so make sure that they go through the right holes. It's very important. There you go, we're going to tape that down. Alright. And again, I'm going to solder maybe 1 or 2 pins here, just to make sure, and take that off. So I just want them held in place, but make sure they're aligned. And again, this is an advanced technique, so if you're uncomfortable doing that, just make sure you tape it down very well. But I did pick it up and solder that 1 pin just a little bit so that I can maneuver the header so that it's correct and flush. Okay. Once all that's good, then we go ahead and solder the rest of our pins on in for these headers. It's been a little ornery. Alright, now we're going to solder wires on the front, red, D3 to the positive below A, and then another red from E3 to F10, okay, black ground wire from D4 to the ground to negative below A, black from E4 to E5, and a brown from G4 to G12. once our board is cleaned up, we're going to start soldering a few more things onto the front, starting with our capacitor, 0.1 microfarad non-polarized capacitor from I4 to I5, a yellow wire from D5 to B27, a green wire from D7 to B28, a blue wire from D6 to B29, a gray wire from D8 to A50, a yellow wire from F6 to B45, and a purple wire from F7 to B46. And I like to leave a little bit of slack in each one of these, just a bit, so I make a nice little curve. Okay. And you'll realize why once you start putting these inside of the lower housing. Now, once you have all the wires installed and your board cleaned up, you are going to install the SD and GPS breakouts. Okay, so here's where you're going to need the little white spacer there on the assembly board, and that is to hold in the SD breakout. That's an alignment piece, and you'll notice the two little holes there. It's once you have it, straight and flush, it holds it pretty well. Okay, make sure all the wires are tucked in. There we go. And so that the proto board lays flush. Boom. We're going to solder this guy on in. Okay, make sure the solder joints are good. All right. Next, we're going to have and we can test the SD card out first to make sure that the SD card is running. So that's why I plugged it into the USB-C. And I'll have all the test codes up and for the GPS as well. So and we're going to put in the GPS. Okay, you'll notice the little stand there, and that will hold the GPS. That will help you align the GPS. Make sure you put in your battery for the GPS. There you go. Battery's in, flux, and we're going to solder our GPS breakout in. Got our 2 points of contact with the rim and the pin. Little volcanoes, best we can. There we go. Should be pretty darn aligned. Now, when I do the SD card, I do kind of like putting in the SD card in as well, just to make sure. We will be using the USB-C cable in just a minute. If the light didn't come on the GPS, then there might be an issue. Okay, so right now, I believe I'm plug your USB-C cable into your computer, into your microcontroller there. Okay, go to your test codes, drag and drop SD card into CircuitPy folder or drive. Okay, and once it's done copying, you won't see too much on the serial. I'll just say program complete, but you can check your SD card and there should be stuff in there. Next, move on to the GPS. You do the same thing, drag and drop. Okay, check your serial. And once it's in there, your serial should come up. It should say that it's finding the firmware, and it should be looking for a fix. Okay, usually if it's indoors, it's not going to find a fix. Okay, but that just means that your GPS is actually working and trying to do that. Cool. Now we're going to install the power button. So this is relatively easy. You might have to move some wires out of the way. Again, another reason to put a little slack in them. Just a touch. Okay, so you solder a gray wire from J54 to B43. And then once you've done that, install the button on the rear. Make sure that you trim solder joint flush to the board. You just trim them down a bit, make sure that they're as flat as possible for the most part. Then install the button. Okay, with the body towards A60. Okay, and make sure that's all through there. And try not to melt any wires when you're soldering it in there. Okay, we taped it all up. There it is. Okay, now when you plug it in, you should be able to turn it on and off with the switch, and the power button is working. Now we're going to put it all together, and we're going to insert our electronics into the lower housing. Okay. First, we're going to install the quick buzzer using the quick connect, and we're going to just install it to the real-time clock. There we go. Okay, remember the shiny side of the quick connects goes towards the board. Okay, make sure we sort of put our iSpy back in here for the display. Okay. And before I start inserting there, I might check it out and make sure everything's running, test all the code, and make sure it's coming up. Okay, so when we're putting this together, we have our tail, our record button, our GPS window. Okay, and then I sort of scoot. You'll see like little fins there that grab on to the front cover there, and then snap everything in. Make sure it's all snapped all over the place. Okay, and alright, once I make sure it's all snapped, then I install the swing door here. Okay, pop that in there. Alright, and put the cap on the rotary encoder, turn it on, turn it off, make sure it's all good to go, check the alignment, make sure everything's good. We can peel off these sides here, so there's just a little retainer area there, and you can put some printout, slip some printout type things in there if you want. And if it's all working, things should boot up. It should beep at you, okay, and it will start to create a menu. And thank you for joining me on building your base module to the Stella 1.2. Please talk to us on our GitHub forum, the community forum there for Stella, and let us know what you're doing with your Stella. That would be most helpful. Also, feel free to ask any questions. Thank you, and good luck measuring.